morning, Pirates. This video is for Thursday, April the 23rd, 2020. Today is National Picnic Day and National Talk Like Shakespeare Day. It'd be hilarious if you went on a picnic and talked like Shakespeare the whole time. I'd love to see the video. We're going to begin this lesson by talking about acid-base reactions. Neutralization. An acid-base mixture is called neutralization, and the resulting mixture is not as acidic or basic as the solutions you started with. Let's look at our diagram. Our base had a pH of 12, so it was very, very basic. Our acid had a pH of 2, so it's pretty acidic, a little more acidic than lemon juice. And when we mix them together, the resulting solution has a pH of 8. Remember, neutral is 7, so this is slightly basic. This table has common salts. We have sodium chloride, used for salting our food. Potassium iodide. This is the iodized salt that prevents iodine deficiency. Calcium chloride is a de-icer for roads and walkways. Potassium chloride is used as a salt substitute in foods for people who are salt sensitive. Calcium carbonate is found in limestones and seashells. Ammonium nitrate is found in fertilizer, and it's the active ingredient in cold packs. Each of these salts is formed by the reaction between an acid and a base. Most acid-base neutralizations will produce some sort of salt and water. Now, I say most because there's always an exception to the rule. This section is about strong and weak acids and bases. Helpful reminder, an acid, anything that donates an H+ is an acid, so anything that donates a hydrogen ion is an acid. What makes something a strong acid? A strong acid dissociates completely in water. This also makes it a strong electrolyte. This means they release all of their hydrogen ions. They donate protons because hydrogen has one proton. A strong acid example, we have some hydrochloric acid, HCl, and it will release all of its hydrogen ions when placed in water. So it becomes H+ and Cl-. Instead of being a molecule, they are now separate ions. Positive ions and negative ions. A weak acid is an acid that disassociates some, releasing only some of its hydrogen ions in the solution. It is less capable than a strong acid at donating protons or hydrogen ions. Our weak acid example, we have some acetic acid, some vinegar, and it breaks apart into CH3, COO with a negative charge, and a hydrogen ion. It keeps some of its hydrogen. Notice it still has H3 in it. This means it did not come completely apart. It is a weak electrolyte. It can weakly conduct electricity. Friendly reminder about bases. Anything that accepts an H+ is a base. A strong base disassociates completely in solution. Bases are proton acceptors. They accept the hydrogen ions. Strong base example, potassium hydroxide becomes K+ and OH-. It completely ionizes into positive and negative, in this case, positive potassium, negative hydroxide, ions in water. A weak base, by contrast, does not completely disassociate in water. Weak base example, ammonia, NH3, and water, H2O, become NH4 with a positive charge and OH with a negative charge. That's hydroxide. Ammonia is a base because it accepts the hydrogen ions. It does not come completely apart in water. It is not completely converting into hydroxide ions. It's keeping some of its hydrogen. Flurf Nugget says, let's go on a picnic and talk like Shakespeare. You guys have a good rest of your week. Your activity for tomorrow is in your digital notebook. Make sure you've been keeping track of the other activities that aren't included in the video. Go back and make sure you're completing everything. I miss you guys.